Hi guys, how are you? Okay, welcome to my channel, and today we are going to look at the absolute function. So today's lesson is going to be on the absolute function, one of the important functions that at least we should introduce at this point in time before we head on to look at things like the evaluation of limits and calculus. So it will be good to just do an introduction of that. So in this lesson, our main objectives will be to look at least three things to say. So the first of which will be to define the absolute function. Then the next thing will be to understand some of its properties. Then the last part will be to understand how to obtain the graph of y is equals to f of x from y is equals to fx, like that. So these are the three things that we'll try to look at in this lesson, you see. So yeah, let's begin. So what is an absolute function? What is an absolute function? So far we know from our definition of function that a function is to take things from one set and map them to another set. So in that same manner again, we are going to define what is an absolute function. So an absolute function is the function. So an absolute function is the function which I can represent as some two vertical lines with dot, meaning it takes argument on its interior like that. So it is the absolute function where this function accepts real numbers and gives out positive real numbers, defined as follows. So this thing that we refer to as the absolute function, it takes real numbers and maps, it takes the set of real numbers and maps into a set of positive real numbers, and how it's defined is as follows. So when you give it a, which you can also write as the same thing as saying in function notation, it is equivalent to a every time when a is positive, and it's equivalent to a when a is negative. So that's what the absolute function really is, you see. So let's understand what exactly this function does. So what this function does is that every time when you give it something, let's say now when you want to find f, the function of 3, which you can write as 3, what it does is that this function checks the nature of the number that you submit to it. So when you give it 3, what it simply does is that it checks if that thing is positive or not. So when it sees that the argument that you have given to it is positive, it gives it out as it is. You see that? But in instances whereby you feed it something which is negative, let's say negative 3, which you can write as negative 3, what it does is it checks if it finds that what you have put as an argument is negative, it takes that negative 3 and multiplies it with a negative, and you get a positive 3. So an absolute function is a function which always produces as an output positive things. So it cannot produce anything which is negative. So that's the meaning where I'm using an R plus to mean that you always get something which lives in the space of positive real numbers. So that's what an absolute function really is in simple terms. You see, so this definition is just equivalent to just saying what is positive is given out as it is, what is negative is multiplied by negative to make it positive. You see. So that's all that we can say for now when it comes to the absolute function. So this thing that is called the absolute function, it has some nice properties that are associated with it. And now we're going to look at those properties of the absolute function. You see. So the first property of absolute function is teaching us on how to deal with products. So if you want to find the absolute value of a product of AB, which is just the same as the absolute value of A times B, it is just the absolute value of A times the absolute value of B, like that. You see, so that's one property that the absolute function has, is that when you want to find the absolute of a product, it is the product of the absolutes, like that. Then two, the other thing is that when you want to find the absolute value of, so when you want to find the absolute value of A over P, this is the same thing as just saying the absolute value of A over absolute value of P. And make sure that B is not equal to 0, and also B must be an element of real numbers. So those are things that you must make sure that you pay attention to. So A and B must all be element of real numbers in this case. You see. Then thirdly, the other thing that you should know is that the absolute value of A plus B is never equal to the absolute value of A plus the absolute value of B. So this is a property that you must know, that you can't do something like this when it comes to absolute functions, where the absolute of the sum is the sum of the absolutes. It's not true. But what is true is this. So what you have to know is that the absolute value of A plus or minus B is less than equal to the absolute value of A, thus the absolute value of B. You see. So this is a very important inequality in real numbers, which also has a name and is known as the triangle inequality. So it's a very important inequality to know, as at times it can be used for optimization purposes, which we are going to see maybe when we do some miscellaneous problem after the end of the discussion of the absolute function completely. So these are things that you must make sure that by now you master them and you are able to practice all these things. You see. Okay, so now let's see what else. So now what we want to do is we want to see now if we have managed to get everything that we have learned so far. So let's see if we can be able to answer questions as follows. So example, given that x is a number which is greater than 5, write the following in terms of x without the absolute function. So write the following in terms of x without the absolute function. A, we are given x plus 2, and then B, we are given 2 minus x, and then C, we are given what? The absolute value of 4 minus x squared, like that. So how can you write this in terms of x, given that x has that condition that is given there? So how can we deal with that? So let's see how to answer this problem. So solution. So the first thing that we want to answer is what is the absolute value of x plus 2. So we know that since x is greater than 5, we can agree that x plus 2 is something positive. So since this is something positive, it means the absolute value will just give us x plus 2 as it is without the absolute function. So that's what is going to happen. Then B, now we want to find the absolute value of 2 minus x. So we see now that x is greater than 5, and we are 2 is separating x. So which means every time when I say 2 minus x, I'll always be getting things that are negative because 2 is greater than 5. So we know that the absolute function will check what is on the interior and is going to multiply that with a negative to make it positive, which will simplify at the end of the day to just become x minus 2, like that. Then C, also want to evaluate 4 minus x squared under the same condition. So one thing, one can see that this is a difference of 2 squares, where you can write this I can write this as 2 minus x and 2 plus x. And what does that give us? So we see that by the properties, this is the same as saying 2 minus x, 2 plus x. So we have seen already that the thing on the left will come out as x minus 2, and the thing on the right will just come out as 2 plus x. So which will just be simply as x minus 2, x plus 2, and that's it. So if you want, you can also write it as x squared minus 4. But now I just wanted to do this way just to show also how to play around with the properties of the absolute function. You see. So these are things that you must pay attention to. And the other thing that you must pay attention to is this result. So pay attention to what is happening here. The absolute value of any number is greater than 0 for any real number that you can put. So you can't have the absolute function coming out as negative. So we see that this thing is always positive all the time. So it's very important, though this result is trivial, it's very important to always be aware about it at all times. You see. So now we have come to understood the absolute function, and we have played around with some of the properties of the absolute function, though some will meet them in later cases. So now what we're going to do now is we're going to move on to start looking at the curve sketching of functions that now we have imposed the absolute function. So what we want is to see how exactly does the absolute function affect functions. You see, that's what we're going to do now. So the title of what we want to look at is sketching y is absolute of f of x from y is equals to f of x. That's what we want to look at this point in time. You see. So how can we sketch an absolute function? So to sketch an absolute function, let's first understand some things. You see that? So we know that a typical function, so if you have maybe a typical function f of x can be something like this. You see that? So a typical function can be something like this in most cases, where you just have a plot and you have a function that lies inside there behaving differently like that. So a typical function can be something like this. You see. But now what is it that we recognize when it comes to a function? You see that? So if you are to study a graph of a function, you will see that the graph of a function is made up of two parts. You see that? So a graph of a function is what are known as positive sections, and it is what are known as negative section. So what do we mean by that? So let's come maybe and look at the following things. If you are to look at this portion of the graph that I'm going to highlight at this instant, you will see that all these portions that I've highlighted, they're always above the x-axis. And all these portions, one thing that characterizes them is that for all these things that I've highlighted, for all these sections that I've highlighted, this one, that one, one thing is that we can see is that f of x is always greater than 0 in all those situations. You see that? So the portion of a function which lies above the x-axis, we call that a positive section of a function. So all these things that I've highlighted in green, they are positive sections for the function because the function always evaluates to a positive number whenever you are to take any points on that particular section. So if you take a point here, you'll see the value of the function is positive. Take a point here, you see the value of the function is positive. Take any point here, again, the value of the function is positive, even here as well. You see. So which means we can see that what we call the graph of a function, it is a chain of positive and negative sections of a function joined together at some stage, at some instant or at times. But that's one thing that we can actually use to define a function, that it is a chain of positive and negative sections of a function. That's what a function is made up of, you see. So if you had to study now the other part, like for example, if we come here maybe down, you can see that also besides having positive, we have these sections like the ones that I highlight here in brown. So these sections that I've highlighted here in brown, the function will always give us something which is positive, always at those regions. So if you are to study this area, study that area, study that area. So one thing that you will see is that the function f of x will always be negative in all those regions. You see that? So the function will always be less than 0. So at the points where the negative sections and the positive sections meet, that's where the function now is actually 0. You see that? Because these have to be true at the same time. So at those points that I've highlighted in white, f of x must be greater than 0 and less than 0 at the same time, which tells us that the function becomes 0 at that instant. So sections like these that I've highlighted in brown are what we refer to as negative sections. So we refer to these parts as negative sections or negative portions, whatever you want to refer to them as. And then the top ones, these ones that I've highlighted here, we refer to these as positive sections. You see, so those are things that you should know, that a function is made up of what are known as positive sections and what are known as negative sections. So when it comes to knowing how the graph of y is equals to absolute value of x can be obtained from that of y is equals to f of x, it is always a good point to be aware of this kind of knowledge or terminology that you have introduced here, that they are what are known as negative sections and are what you know as positive sections. So now, how can we then use this knowledge to construct absolute f of x from f of x? So let's write down as a result. You see, so the graph of y is equals to f of x can be obtained from the graph of y is equals to f of x by reflecting negative sections of y is equal to f of x about the x-axis. You see, so remember, what we want to learn is actually how can one plot a graph of y is equal to absolute value of f of x if you are aware on how to actually sketch the graph of f of x. So what this line is trying to tell us is actually giving us a way on how actually you can obtain that graph from this one. So every time when you want to find the graph of the absolute of f of x, knowing f of x, you can simply modify f of x just by taking the negative sections of f of x and reflecting them backwards, and then what you will obtain is the graph of the absolute function. So what exactly are we trying to say here? So let's try to give some illustration. So to give some illustration, let's look at the following. Suppose you have the following graph on the left. So let's suppose you have the following graph on the left. And this is the graph of f of x. And the question now is, how can you deduce the graph of the absolute of f of x from the one of f of x that we have here? You see that? So if you want to deduce the graph of the absolute of f of x from the one of f of x that we have here, the first thing that you have to do is first you have to go and locate the negative sections of this graph. So let's look at the negative sections of this graph. We see that the negative sections of this graph are this one and this one. These are the only two negative sections that we have. So the only thing that now you have to do in order to get the graph that you're looking for is to take those negative sections and reflect them backwards. So instead of keeping them in the negative side of the x-axis, what you do is you reflect them back so that they come there and also come there, which will then finally give you a graph which has the following structure. So at the end of the day, you will have a graph which has the following structure. You see, so this graph that we have now is the one for the absolute value of f of x that you are looking for. So this is simply how you actually sketch graphs of absolute functions from the original functions. So first you just have to apply your skills and knowledge on f of x, get the sketch of f of x. Then the next thing is just to observe the negative parts of the graph of f of x, and then you reflect them backwards. So when you reflect these graphs backwards, then you will see that what you obtain is the graph that you are looking for. You see that? So one thing that you should also know is that when it comes, at times you have to do some labeling when you have sketched a graph like this one. So what you should know is that the parts that are reflected, they always have their equation described by negative f of x. So all parts that were obtained by reflection, they have their equations described by negative f of x, like that. So this is how or some basic knowledge that you have to know if you want to be able to sketch absolute functions from the original graph of functions that you have. So in order to see how and to practice how this works, let's look at just different examples on how to sketch absolute functions. So the first example that we're going to look at is going to be as follows. So given that y is equals to minus 4x plus 3, sketch the graph of y and that of the absolute of y on different set of x's. You see, so given that y is described that way, sketch the graph of y at first and that of the absolute value of y on different set of x's. You see, so how can we sketch these two graphs? So let's see how to solve for that. So to solve for that, we proceed as follows. So first we'll consider the thing that we are looking at. So we'll say let's consider y is equals to minus 4x plus 3. Then we know the basics that first we have to find the intercept. So we say when x is 0, what is y? We see y is 3. Then we come and say when y is 0, what is x? So when y is 0, we see that you can take x that side, then you get your thing as 3/4. So which means now we can actually sketch the graph of y, and how will it look like? So from the knowledge that we have, we know that the graph of y will look as follows. So let's sketch it. So since it crosses at y3 and x3/4, it crosses at positive parts, so it's going to be something like this. You see, so it's going to be, this is going to be y is equals to minus 4x plus 3. So you can even label these points that this is happening at 3 and this is happening at 3/4, like that. So this gives us the plot of y. The question now is, how can we plot then the absolute of y from this plot? So you know now that if you want to obtain the absolute of y from this plot, it's time now to go and locate the negative part of this plot. So we know that the negative part of this plot, it is only this portion only. So which means now I just have to take this portion and reflect it backwards. So when I reflect it backwards, what is going to happen? You see that? So what is going to happen? So when I reflect it backwards, it means the plot of the absolute value that I'm looking for will be as follows. So I'll have my graph coming first the normal way as it was coming, and then when it reaches this point, it can't protrude. So the part that was supposed to go to the negative side is reflected back, and we go back like that. You see, so here we're still at 3/4 and here we're still at 3, but the negative portion of the graph is now reflected backwards. You see, sometimes you can be asked to label it. So to label it, you can see that this is the unreflected section. So all sections of a graph that were not reflected, they take the original equation of the curve, which means the equation of this will just be negative 4x plus 3. Then what we have here now, this is the reflected section. You see, and the equation of the reflected section is always obtained by taking that of the original and multiplying by negative. So if you multiply by negative, you get 4x minus 3, like that. So this is how you get to sketch the graph of an absolute function if you happen to know that of the original function, like that. You see. So let's practice more and more examples till we can see what's going on here. So another example that we have is as follows. So given that y is equals to f of x, with f of x equals to 4 minus x squared, sketch the graph of y is equals to absolute of f of x, like that. So this is now the question that we have. We are given the graph of f of x, and then we are asked to plot that of absolute value of x. So how will you proceed from here? So how we proceed from here is as follows. So first we have to find the intercept. So what we're going to do is we'll say consider the plot without the absolute. So I'll consider first 4 minus x squared. So what we see now, we'll see that when x is 0, y is just 4. And then when y is 0, you will get 4 minus x squared is equals to 0, which will give you at the end of the day that 2 minus x, 2 plus x is equals to 0, which will imply that x is equals to plus or minus 2. So this is a parabola with a maximum value, which means if you are to now plot the function that we have at this instant, it will be something like this. So we have y 0 x, and the plot of this function is something that is like this. You see, so here it crosses at minus 2, here it crosses at plus 2, and this is the function y is equals to 4 minus x squared. So now we have to see how we can obtain that of the absolute from this plot. So to obtain that of the absolute from this plot, now we have to mark the negative sections of this plot. So let's try and recognize them. So we see that the negative section is this one and this one. So I have to take this negative section, reflect them where they are coming from. You see, so reflect them back around the y-axis. So let's see now what will happen when I do that reflection. So I see now that my plot that I'm looking for will be something like this now. So this is what is going to be the case. So first I'll have that interior region which was not reflected, which lies like that. Then these other sections are reflected, they go back, and they go back, and this is what I obtain. So I'm still here sitting at -2 and +2. So if you pay attention, this is a reflected region. And this is another reflected section again. So which means if I want to find what are the labels for these two sections, you multiply by negative that of the original, so you'll get x squared -4, and also the label of that portion is y is equals to x squared -4. But for the original one, it still keeps the original equation, which is 4 minus x squared, like that. You see. So this is how you get to sketch the absolute function from the original function. So these are very simple sketches that one has to be aware of and know how to do pretty well, you see. So this logic applies to whatever the curve is like. So whatever the curve is, you will always have to apply these rules. If you have you want the graph of the absolute function, if you are aware of the original function without the absolute, you see. So these are very tricky situations that one has to learn pretty well on how to deal with. Then now what we want is we want to look at some other complicated problems that can be very difficult to handle at times. So let's just say more on curve sketching. Let's look at more on curve sketching. So to look more on curve sketching, at times you can be asked to sketch things that are quite complex. You see, so you can be given maybe a problem as follows. Sketch the graph of y is equals to negative 2x plus 1 plus 6. So sometimes you can be asked to sketch some complicated plots like the one that I've just written here. So the question is, how can one actually deal with the problems like these? So what can we recognize at first? So if you are to look deeply at what we have now, you will see now that there are things that are happening that we haven't dealt with before. Now we want to sketch a graph. This graph function involves an absolute function, but besides that, there are things that lie outside the absolute function. We see there is this, there is this. So we should understand what is the meaning of all these things, you see. So every time when you see negatives outside of an absolute function like the one that you are seeing here, these negatives, they always stand for reflections about the x-axis. So every time when you see things like negatives outside the absolute function, they always stands for reflections about the x-axis. And when you see things like these refers to vertical translations. You see, so every number that is either being added or separated outside of an absolute function, it always stands for vertical translations. So what we want to see now is how then can we now plot this curve that we have here, provided all this knowledge that we have just stated here. So now let's see how to go about that. So one way to deal with cases like this one is as follows. So let's see. So every time when they give you something such complex, the first thing is just focus on just the absolute part without having to incorporate these things that lie outside the absolute function. So what I'm going to do, instead of considering everything, I'll just consider my y is equals to 2x plus 1. So that's what I'm going to do. Then using this thing, I'm just going to plot the graph of this thing that I know. So we see now that when x is 0, from this y is 1, and then when y is 0 from this, we see that x is equals to negative half. So now let's plot this curve and see how it's going to come out like. You see. So we see now that if I want to plot this curve that I have here, this is how I'm going to do it. So I'm going to first see where it's supposed to cross. It's supposed to cross at 1 and negative half. So which means it's supposed to cross in the positive in x and in the negative in y, which means this is a curve that is supposed to come like this. But as soon as it reaches there, I remember that my goal is actually to plot an absolute, not the original function. So instead of continuing going to the negative side, I'm going to take that part which was supposed to negative and reflect it back. So that's what I get. So here I still sit at negative half, and here I sit at 1. Then now I label. So the left-hand side is the unreflected portion. Since it's the unreflected portion, I get 2x plus 1. And for the reflected portion, I get minus 2x minus 1. Like that. You see. But remember, the overall graph that we have just plotted here, you see, so the overall graph that we have just plotted in this region is simple. Y is equals to absolute value of 2x plus 1. This is what we've just plotted here. So now the question is, how can we now deal with these other things? So first, let's start with the negative. So how will the negative change things here? So if you now apply the negative outside the absolute function, that negative will take our original graph and reflect it about the x. So this thing is going to face downwards, which means the graph of minus will be something like this. So now we're going to get something of this sort. So our graph is going to be reflected like that region. So we're going to get something like, which goes like that. So we're still at negative half here. But since now we're reflecting, instead of having positive 1 here, we're going to sit now at negative 1. You see. So when we reflect, the portions, they swap equations. So the equation that was on the left comes to the right, and that on the right comes to the left. So this one simply becomes y is 2x plus 1, and this one becomes y is negative 2x, negative 1. But remember, the overall graph that we have just plotted here now, it is y is equals to minus 2x plus 1. So that's what we have just plotted at this instant. So the question now is, how can we now incorporate the 6 that is sitting outside? So remember, the 6 means vertical shifting. So if it's a positive, it means a vertical shift upwards 6 units. If it's negative, it means a vertical shift downwards 6 units. So what we're going to do now is we're going to take this graph and raise it 6 units up. So when we do that, the final curve that we're going to get will be something like this. So we're going to get a graph which is something like this now. Like that. You see. So here it's still located at negative half. And here it will go to 6. Because if you look previously, this thing point was sitting at y0 there. So which means when we raise 6 units up, it has to go to y6, which gives us that. Now, how do you label these equations? So to label these two graphs is simple. To label this one, you just take the graph the equation that it had previously, which is this one, and then you add 6 to it. So when you add 6 to that, you get negative 2x plus 5. So you get negative 2x plus 5. Same thing even here, you take its original equation that it had previously and add 6 to it. So you get 2x plus 7. So here you will just get 2x plus 7. So this gives us the equations of these. Now, knowing the equations, you can easily label all these other points. You see. So to label what this point is, I use my equation, this one, and study it. And I say, what happens when y is 0? So I see that when y is 0, I get negative 7 over 2. So this point is at negative 7 over 2. And then I go to that point, I use the equation on the right. I say when x is 0, y is 5, I get that. Then I see that when y is 0, I get 5 over 2. So that point is 5 over 2. So therefore, this equation that I have here now is the equation that we are looking for. So this is the equation for the full plot now of y is equals to negative 2x plus 1 plus 6. So these are things that you should know when it comes to absolute function, how to deal with all these different cases. So here I've shown you how to deal with the things that lie outside the absolute function, because sometimes they can pop up in curve sketching, so you should know. So this same procedure works even if the function is not a straight line function like this one, even if it's parabolic function or whatever, the same principles, they always work. So a negative outside an absolute function means a reflection, as long it's multiplying that portion of the absolute function, and anything which is added outside the absolute function, it means vertical translations or shift, like that. So yeah, those are some of the basic things that you should know when it comes to absolute functions. So today we are not going to do anything further than this. We are going to just end this section here today. Otherwise, yeah, you can watch the videos, and it will be great to hear any comments coming from you guys if these videos are quite helpful and they are making you understand all these concepts. Or maybe if you feel like there are ways to improve these videos, it will be good also to hear your views in the comment section. Otherwise, thanks very much for watching, guys. See you